Good morning. Good morning. I'm so happy to be here. This is my first time presenting at UtahJS, and I'm excited about this. Hopefully, you get some really good information out of this talk. I am going to be talking about complex state and React. Earlier this morning, I heard a conversation where someone was just comparing stacks, right? This is UtahJS, it's not Utah React. And so we are at there are many talks about many different technologies this morning. And so who here uses React? Okay. Who here uses a stack that's not React? Maybe you're going to answer twice, but who here uses a stack that's not React? Okay, just a few of you. I was a little skeptical. We moved from Polymer to React, and Polymer was very object-oriented, and the browser used the platform. And when the promise when we moved to React was that we would have it would be 20% faster coding. And I was skeptical. I had never really used React before. We had announced that we were going towards it. And I was like, really? That's a lot faster. And when we rolled out React, we rolled it out with a design system that's actually a really good design system. And the truth is that now we're 50% faster. So there's React for you, and design systems. That's my plug for React if you're not really sure at the moment. But if you're already here, you're here for complex state. So let's talk about complex state. So what is that? That's many interconnected state changes in many React components. I was practicing my slide I had my slide deck up. I just had one slide up, and it was my use state slide earlier, and somebody came down and was like, so are you going to talk about more than use state, or is that your talk? I was like, oh, wait, there's more. There's so much more to React than use state. There's a lot to it. So why does it matter that we know all the things? Well-organized code is easier to test, it's easier to refactor, and it's easier to improve. It's easier to add new components, add new features. Your PM wants that new thing right away. It's easier if you know where your code is, right? And because it's easier, it's cheaper. It's cheaper to keep your product running over many years. And the longer that product lives, the more it matters that you are well organized, that your code is readable, like we heard about earlier, that your code is well done, because it's cheaper to let it live. And, or did we just code ourselves out of a job because our code is running smoothly? Let me promise you right now that the reward for a job well done is more work. There will be more. There will be new ideas and new things to build, and you can go on to more fun, challenging projects. So my number one rule for complex state is to break down that hard problem into simpler problems. You want easier problems, and then you break those easier problems into even easier problems, and you're solving an easy thing. And that is the best way to handle it. Now, when you break it up or break it down, however you do it, there's a lot of ways to do it. You can cut this carrot in many ways, and you can do the same thing with coding. The answers are never one size fits all. And so we'll go over the building blocks, and then we'll talk about combining them in a good way to make our complicated problem work well. So what are the building blocks? It's hard to just kind of separate them into this is a bucket, this is a thing, but I'm trying to help kind of organize it. So we have our state management and then our state buckets, and they'll kind of sort of overlap a little. And then we have composition. So state management is just how we manage our state. Where we put it is the state bucket, and the composition is how we organize everything all together. So we'll start with the state management building blocks. The basic building blocks really in React are props, Derived variables, use state, and use reducer. And in my mind, I start at with props. You always start easier and then you add complexity, because if you start adding stuff that's really complicated to begin with, you're going to end up with complexity you don't need. What you really want to do is organize it so the complexity is what you is in the areas that matter most, right? Props. In a React component, props are passed in. It's very simple. It's useful for passing state from one component to another. And one of those props is children, so we'll talk about that more in composition. Derived variables are derived from other state at render time. So this is a variable that's not going to change when something else changes. When a user clicks a button, or once you make a network call because a user clicked a button or whatever, they will get reset every render. So the top one is a translation. It's super cheap because everything's in memory, and we don't need to worry about that being reset every render. The second one is a little more complicated. There's some parsing involved. And so we cache it and reset that derived variable when we need to using use memo. And so you choose this one when a variable only changes on render. And it actually is a really important part of React. We sometimes forget about it, but it's actually really important. Next is use state, and a state variable that can be modified outside of our initial render. So we've all seen this. It's one of our basic building blocks of React. At the beginning, in the parameter, we put the initial value, and then we have our set state function that can be updated outside of the render cycle, and then our state variable. One interesting thing about useState that I'm just going to say is this is an array, and because it is an array, it can be reused and renamed. We can rename whatever gets returned from useState, and that makes it really easy to code with and easy to use again. And then that can be passed to lower components, and when it gets into that lower component, it becomes a prop, not a use state. And so in that, there's a different perspective once you get into the new component. And this is useful for simple scenarios with updates that are outside of our render cycle. Use reducer is the next one. This one's a little bit harder. It's a little bit more complex. It's a state machine, right? For complex state, we've used state machines all over, and you probably used a reducer, but I'm going to go into it because some people just sort of avoid it because it's kind of hard. It's useful for changing multiple interconnected values together in lockstep. And the API can be intimidating, but it's not actually that hard once you learn. So when I was one of my earlier jobs, early 2000s, this was before we really had GitHub and really good code review processes and everything. And so my mentor would have some code, and we were using Perl at the time, and he had this code, and he had all these map functions, and I was like, oh, he's part-time. I'm not going to worry about what he cares about the code. And so I changed them all to for loops because I wasn't really familiar with maps. And he came to me, and he was like, it's not that hard. Just learn it, right? And I just learned it, and then I loved it, right? And now it's pervasive, especially in React, which is lovely. I love maps and love filters now because I had to learn it, and once I did, I was so much gladder, so much happier that I had that exposure. And I feel like a reducer is kind of the same thing. Once you really fully understand a reducer, you'll gravitate to it when it's when it really is the right choice to use, right? So I'm going to go into a data fetching example. You have a custom hook. I like to put reducers and custom hooks. One of the things is encapsulation, right? That means I can make changes without really affecting the rest of my components if I put it in a custom hook. So we have our 3 states, our loading state, our success state, and our error state. And then things, how we change them, decision points. So with a reducer, you pass in a function. It's really simple. It's just a pure function, which means there's no side effects. There's no extra things going on with it. So we just pass in something and we return something. We get the old state and we return the new state and any actions that go along with it. So our success state, our success case is here. We return some data and our status. And in an error, we just return the error and the error value. And then in loading, we just return just that we're loading. And when it goes to use the reducer, we just put the reducer function in our use reducer hook. Now notice this looks a lot like use state. We have our initial state, and that could be a function if it gets complicated. And then we have our state variable for reading the state, and then we have our dispatch, which looks a lot like set state, except it's just a tiny bit more complex because we can do a little bit more, and we can encapsulate all the complexity of the reducer, and it looks just like a use state. So when we go to change the state, we call dispatch. Here we do a fetch, and we dispatch the response in a good case, and then we dispatch the error in an error situation. Pretty simple. That's our set state. And so we create a custom hook that will then use the reducer and return some state, right? We call use collection, and it starts with use, it's a custom hook. And then we call our use reducer like we talked about. And I didn't include all of the data in here, but it's the last slide. We do a thing and call dispatch to change the state, and then we return our values from this hook, and our data, our status, and our error. And then we can use this custom hook just like we would any other custom hook. We've written an API. Call your custom hook for your reducer state with the data you need, and then the collection status and error will always update as needed. And when the collection ID changes, we can redo it, right? So our UI component really is able to focus on the UI. We return the error, we return loading UI, and we return the happy path UI, right? And that is it. When it comes time to unit test, when we've put every state of our reducer in our unit tests, we get 100% coverage. And I love that because I love code coverage because I know I can refactor and I'm gonna not have problems. So in this case, as we're doing a basic unit test, we have our component and we pass in a collection ID that's bogus. And so we expect to find the not found text in our error component, and we've tested our error case. Super easy. When it gets to be a little more complex, then here are a couple thoughts about use reducer and testing it when it's complex. Use reducer itself is part of a UI framework. It really is. It's React, right? Because it's a custom hook. So in my mind, it's UI. Any complex logic that might be in your switch statement should be moved into other functions and treated as functions that are tested independently. That way, your reducer is a little bit more simple and it's easier to test each situation. If you need to test your reducer independently of the UI, like you're exporting your custom hook that has a reducer in it, and so you want to test your custom hook, I love to just make a fake UI. And I just make a component that displays the actual state, and then I'm testing the UI the way I would the React framework. You can also use React Hooks testing library, but luckily it's not very challenging to test a reducer. And I am going to show you a diagram of a reducer. Doesn't this look great? Super easy, right? This is, I took out the actual things, but this is the way a reducer was at some point, a family search. Families are not simple. They just aren't. My family's not simple, and yours probably maybe is, maybe it's not. But even the perfect families aren't easy. In this diagram, you can see the purple part each of these is basically our cases in that switch statement for the reducer. The white part down below, those are algorithms that would be called in various situations. And this is where we can go unit test each one separately. And then the yellow part are functions that get exported from a context. And then we can call each situation when that happens, right? This one supports things like drag and drop and users changing things. And then we return an updated family situation. And so this is just an example. When you're dealing with a lot of interconnected state, you want to grab something like a reducer. It's right there, and it's made for this. So next are the state buckets. And okay, we're going to go a little bit overlappy here. But custom hooks is my first kind of sort of state bucket, kind of sort of state manager, because I just used one, right, in my example for the reducer. And then we have context, and we have other state buckets that are non-React. Okay, so our custom hooks, they're kind of sort of state buckets. They're kind of managers, but let's take a look. We have a function that combines various similar state data. It might use a context, it might use other custom hooks, but what it does is it returns an organized state object that can then be used in your component. And it can return a function to update certain state if needed. And it's great. Custom hooks should definitely be in your toolkit for managing complex state. Contexts are also important. They broadcast and share state among child components. And in a way that you don't have to pass the props down, you can just use a hook to get to those props at any time. This is an example of some old code that we had that's not in use anymore from our Polymer days. And you could see the props are passed in like over and over and over again. And we have like hundreds and hundreds of lines of stuff like this where we're passing every prop, and we have to pass it through every single level. And if we miss a level, then we have a bug. Or if we miss one of these, then we have a bug, and they're hard to find. And this is part of why it's just faster to use React if you're not and don't prop drill. So contexts are all about getting away from that prop drilling. But they are not state managers. They are state buckets, but they can contain state managers. So this is where we pull in our state variables and our state managers into our context bucket. We can use props, we can use derive state, use state, and use reducer, and we can grab our custom hooks as well. And how we decide that, that's why we get paid the big bucks, right? Here's an example of a context use, and this is from my code example. I have a repository that has some of the things that I've talked about today in it, and my presentation that I'll share later. So in this situation, in the top right, users can set preferences for how they want their search results to appear over there. And they're in different parts of the UI. We could completely move them, and yet they're the same. They're dealing with the same thing. So this is the perfect example of using a context. You'll find contexts become useful a lot once you learn to reach for them. So this is what my context code looks like as an example. First, I create context from React, and I create this context variable. I have not exported it. And this is encapsulation. Encapsulation is really important when you're dealing with complex things, because when you put a hard thing in a single place and don't let it leak elsewhere, it's a lot easier to refactor. And refactoring is one of the key parts. So we export our provider component, which brings in our context provider, and then we put the value, and that is what is available in our custom, in our context variable, and we can return it. I love to create a custom hook that exports the context data, and we call use context directly in this hook, but we don't call it from anywhere else. And I put them in the same file, and then I can change or add or move around the things in that object as much as I need to. When I go to use it, I put my provider in my component, and I pass in the initial data, and then context hooks are available from the children. They're not available in this component. It's available inside the inner component. So the child component here will use the hook, and we'll just make the changes by calling the function that's returned to the hook. And look, this particular custom hook looks kind of sort of, it's not an array, but it's kind of sort of like use state. Again, we use the same patterns because they're familiar, and that makes it a lot easier to manage your complex state. Familiarity is important when you're doing something. If you do things the same way, it's a lot easier to understand them as time goes on. So organizing our context, search results. This is a search results page. It has some top level context. It has the filters over there have their own context with stuff, and then the component on the side has its own context. And some of these inner components might be used independently from the search results, and so they are built to be able to work together or not as needed. So that is our state buckets, but for React. But there's more. Sometimes you really need to keep your state in a place that the user has control over it. And especially for search results, I love to use a URL query string as my state holder, because the user can use the back button, they can bookmark it, they can come back to it, and I haven't had to do a lot more than just keep it in the query string. There's also local storage, which I prefer for caching as an enhancement. I don't like to just put stuff that's really important in there because it could get lost. And then we have state libraries like Remix, and we call APIs, and those use our browser network cache. And so those are all our additional options, and there are more. But these are some of the ones that I reach for a lot, and I've used them all in my example project. Composition is how we organize all of our state bits into a single cohesive thing. So what are the building blocks here? These are the ones that I kind of categorize it, like we said, they kind of are interconnected, right? Context components are important, and display components, custom hooks, and then our non-React functions are the main building blocks I use for composition. When I'm using context, how do I use composition? I focus on state data and state management in my context. I like to break down those complex contexts, though, into multiple smaller contexts that are separate. Maybe we're dealing with drag and drop, and we have a context for that, and we have a context for highlighting, and we have a context for, the user preferences and all those things, and we can stack them and separate them. And then put each context at the lowest possible level it's needed. Any context data, you put it at the lowest possible level it's needed. Even while you're coding, you just put it as close to where you need it until you add the next piece that is going to need it in that shared parent state, and that's when you refactor to move it up. And then create appropriate custom hooks for those contexts. display components, I prefer to focus on the UI in my display component and not really focus on state management and any of the other stuff. It's just easier to read. It's easier to go and fix UI bugs when it's a UI problem and fix logic bugs when there's a logic problem. So I'll move that logic into custom hooks or contexts. Using custom hooks, the things that I think most about custom hooks is sometimes I will have a single purpose hook, and some will be generic, and they're going to be reusable. So I'll have I might export it even from a library, or sometimes I'm using it a lot from a single context. The one thing, little trick I have is if you have a hook that's going to be reusable, make sure you don't put your use memo and all your logic in there, because that's going to cause performance problems. Put all that use memo and all that logic into your context, because every time you use a hook, you create a brand new instance, and you're going to be use memoing all over and where you thought you only did it once. Components themselves, they can use multiple hooks, so don't just make a hook per component. Be smart about it. Non-React functions are really important. Move your logic into their own functions and keep them out of the React if you can, and break those into smaller functions as needed. We have this family history file system where we store a file called JEDCOMX, and it's really complicated. And so we have to kind of parse this JEDCOMX, and we had this in the Polymer world. We had this like 3,000 line file that had all the different things in it, and then when we moved to React, I made like 10 different files that were focused on little parts. And then I made sure that they were all like focused on the thing that they needed and had really organized unit tests. And that made the library really stable and easy to use and reuse as needed. And then your functions that you create for non-React logic get unit tested separately from React, and that makes them more stable, and maybe they can be reused when you change frameworks, if you ever do that, or if you add a framework. There's one thing that didn't really fit in my other organization, React single source of truth principle. This is the most important principle. If you don't understand it and use it, you really need to learn it. Data has one source of truth, and it only flows down. Two similar variables shouldn't try and keep each other in sync from like underneath, right? We had this search results page that had pagination, where we had what page we were on, and then we had like how many per page, and each one would kind of set this like page number, and then offset and count were the parameters, and so each one would kind of do its own calculation, and it was a mess, and there were all sorts of bugs. And what we did was we changed it, so we made an upper level state reducer where we could actually call dispatch. Oh, I'm changing the page number. Oh, I'm changing how many per page. And that solved all our problems, and it's been stable since. And that's really a good example of this single source of truth principle. If another variable is simple, can you use derived state? Can you set the variable based on another variable like a derived state, or do you need to put them into a reducer or some other way of setting the two variables at the same time? Look at it and find where the highest common denominator is. All right, we've talked about state management and state buckets and composition. So how do we combine it all into actual like coding the React hard problems? A lot of times we will have a project that we're jumped into, and we get to maintain someone else's code, and it's not the funnest. And sometimes we start our own project, and we're not quite sure where to start. So we're going to start at how to start a complex project. Find the foundation of that project. What do I do first? And then fetch some data, create a provider, create a component, just get started, do a little bit, and then write some unit tests and commit that. And then add more features piece by piece, one at a time. And don't start building your giant framework to start with. Start with the framers. Start with each piece. This is how we do agile programming and when we're thinking about it in project management, but this is an agile programming that's kind of similar, where we add each function as it's needed and don't over-engineer to start. But refactor frequently to keep things maintainable. And as soon as possible, split up the work among the people on your team. I had a brilliant team, especially when I started some of these harder React State issues, but I found that they were a lot more engaged once they'd actually added some code and they realized, I'm going to have to maintain this thing. I'm going to have to fix the bugs in here. And then we got more engaged pull request reviews, and it was lovely, and we got more people building the project. So organize your data as you add features. Separate your complex data structures into multiple contexts and break up your sections of code into customs hooks. And I have a demo here. And break up the components when they get complicated. Diagram your code. Diagrams are great. You can diagram your data structures, your algorithms, your components. And I have a couple examples. And in these diagrams, they highlight problems. And you're like, oh, that is really weird. I need to refactor that. And they'll bring new people up to speed and help you remember what you actually did last week. It is important to keep them current. It's kind of hard to see, but you can see the different colors. Like there's this purple color, and then the green, and then this blue. Each one of those is a context, and each one of the white boxes is a component, and it diagrams what relies on it. And so something like this is helpful when you have a new person coming in and you're like, hey, you're going to get to work on this really complicated thing. Congratulations. And instead of the intern who, in the old version of this code, was like crying, like, please don't make me go in there. And this time we have a little bit more organized, and they can focus on the one thing they need. And then we can have our algorithms diagrammed. I showed that other one earlier. And that's really helpful. So that's the end of my slides. I'm going to move into the live demo for refactoring complexity. Like was said in my intro, I really love knitting. And I have something in the State Fair right now that I knitted. I have projects, and this is a website that's knitting. It has every knitting pattern ever, and then there's this My Notebook, and I have my stash, which is all my yarn that I've inventoried. I actually, whenever I buy something, I put it in here, and then I have my queue, which is my knitting to-do list, all the fun things I want to make. And then I have my favorites, which are the patterns that I found that I love. So I made a program. Let's get it started. And this time I used Remix, where I can come in and use my knitting stuff. And it uses the Ravelry API, so I can sign in as myself and get to my data. And so I have my queue, and I can resort it, and it actually works and saves it. And then I have my stash, which is it's a search results. I've got all my yarn here, and I've got my pagination and sorting and a different display style like we talked about. And then I have my favorites, which are the favorite yarns favorite patterns that I want to make. I think they're really cute. And I've got my pagination again and my page size. So if we go into the coding here, I am using Remix, and I have a favorites route here. That's my favorites that I built. And so Remix has its thing where it has this loader where you get your data, and then it has my display component. And And so here I have some functions where I'm just changing the pagination, and then I've got my title row where I say my favorites, and input the search input, and then the options. Then if there are favorites, then I show my results, and then I have my pagination. And so I'm going to just talk about a little bit about, we often get to this place where we come in to fix a bug and we're like, this is a mess. Like, how did we even get here? This is ridiculous. And so then we make some new components, and then we refactor. And this is a big part of doing a good job of managing state. You need to refactor a lot. So here I have pagination, and I created a paginator component. And this one, it takes page size, current page, and num pages, and it's right here. So this is when I like to start with the JSX when I'm going to refactor, because it'll bring in hooks and functions when I move something into a new component. So I'm going to just take out this and use my paginator component. And then I have num pages. And num pages is it's a derived variable. Look at that. So I can use it just like that. And then current page is it's passed in from the remix thing, use loader data. I've got page props, which has page size, current page, sort order, search text. So I can pull in that. So it's just page props dot current page. And then page size, page props, current size, or page size. And so then I can just bring in my paginator component in the top, and it's there. So let's take a look. I'm on my favorites. I've got my paginator. I don't really love the way it is. It needs a little more spacing. So let's go in and add some spacing. Margin top, and I'm using Material UI here. It's closest to the design system we use at Family Search. And so let's see. Look, we've got our spacing. Yay! Going back to the favorites, all of a sudden, this on-change page size is in paginator, so I don't need it anymore, so I can remove it. And this on-change page num is in the paginator, so I don't need it anymore. And then my hook use search params is also, I'm using URL query params because it's search results, and that's what I need for search results. And I've cleaned up my page, right? Next, I'm going to do the header. So there's all this JSX, all about the header. We've got our pref options, our search input. So I'm just going to return so it's these grids. I'm just going to replace that with a header row. I'm just going to pull it in here, our header row, and let's take a look at it real quick. Header row, it has the search text, the sort order, the data type, and then the children. And I use children here to just have my header text so that I could change it. I could add a component in there or whatever. And that's a composition decision, right? Search text, sort order, data type. So data type is new. And it lets me put something different in the header row. I'm using it for stash, and I'm using it for pagination. And so it's just a string favorites. And then search text comes from page props. And then sort order is not needed, and we just have children. So I'm just going to put my favorites and save it. And let's see how it goes. There it is. It's my favorite. So I can put my very favorites. And let's see, it changed. All right, so there we are. That's my example. And I have a final slide which has my QR code. So you're welcome to view my thing. I hope this presentation's helped you have ideas for and tools for managing complex state in React. Thank you for your time.